In this clip, so you'll understand the purely Docker end of things, I'll quickly show you how our WordPress application can be built in just a few seconds on a local non-ECS server. Then we'll work through the more complicated steps necessary for preparing and firing up an EC2 launch type version of the same WordPress app, including configuring and launching a cluster, defining the container itself, and passing necessary variables to the application components. In the next clip, I'll do it all over again, but this time as part of a Fargate launch type deployment rather than EC2. On a traditional standalone Docker host server, provisioning a 2-container WordPress site is mind-numbingly simple. Everything begins with the YAML formatted file I call stack.yml. This file defines 2 services, the WordPress front-end server and a MySQL database server. We first tell Docker to pull the latest official WordPress image from Docker Hub. That'll give us a Linux OS with WordPress pre-installed as our base system. Had we wanted to use an image from any other internet-based or local repo, we would have needed to be more specific here. We want users to be able to get to our server from the outside using the default HTTP port 80. Had we wanted to use only HTTPS encrypted connections, we would have set this value to 443, or even a non-standard port number if the need arose. These environment settings will tell WordPress where to look for MySQL and how to log into the database once it finds it. From the perspective of a responsible sysadmin, something I sometimes at least claim I am, including the login credentials in this plain text file is straight up crazy. You're far better off passing credentials as a local environment variable or by using a third-party orchestration tool's secrets manager, but this will have to do for now. The DB service points to the official Docker Hub image of MySQL's 5.7 release. Getting the precise version right is important, as the way MySQL handles data can change from release to release. We repeat the authentication information so MySQL will know what to expect when WordPress comes knocking on its door. Since this will be a multi-tier deployment involving at least 2 containers that need to talk to each other, we'll have to initialize this directory as a Docker swarm. We can then run docker stack deploy, direct it to its configuration information from the stack.yml file we just saw, and call the deployment mywordpress. Within 5 minutes or so, we should be able to enter the public IP address of the Docker host into a browser on the network, and we'll have our database-backed WordPress site all ready for us. The fact that we can create an account with a password tells you that we've successfully connected to MySQL. That was easy. There'll be a bit more to getting the same thing done as an EC2 launch type on ECS. I'm not going to show you how all this works using the AWS Management Console because I seriously doubt that that's the way most admins normally get most of their work done. The console is a useful resource, and it can also be a great way to explore an AWS service for the first time. But I sometimes find the click next cycle just a bit distracting and time-consuming. And when it comes to ECS at least, I don't feel the console even helps me visualize the complexity of the service. So we're going to attack this one from the command line. You should have both the AWS CLI and the more specific ECS CLI installed on your local machine. You can follow the excellent official and up-to-date documentation pages for both tools as they relate to your own operating system. I'm going to set the ball rolling using the ECS CLI Configure tool by creating an ECS cluster in the US East 1 region. Double check to make sure this is the region where you want those resources to exist. I'll give my cluster a name, create a config name, which as far as I can tell will usually be the same as the cluster name, and specify that the cluster is going to be used for projects designed for the EC2 launch type. Next, I'll tell the tool how to pass my credentials to ECS by configuring a profile. You can be 100% sure that I will have deleted this access key long before this course is published, so don't get any funny ideas about trying to use it yourself. And don't you ever expose your own keys this way. Next, we'll need to bring the cluster to life using the ECS CLI up command. The compatibility IAM argument ensures that we'll get all the permissions necessary for the infrastructure parts to run properly together. While I would normally use a smaller T2 micro instance for this type of demo, as I mentioned earlier, this particular project just won't run on those, so we'll go with the T2 medium instead. Finally, we have to tell ECS which configuration to use for the cluster, and that'll be the one we just created. You would normally want to include a reference to an existing encryption key pair that would allow you to use SSH to open remote sessions into your EC2 instances. Since we're not going to do any SSHing for this demo, I'll skip it. This could take a while, but once it's done, if the command worked, we'll be shown the object IDs for each of the resources that were created. Well, we've got a nice cluster running with a couple of shiny new EC2 instances to show for it. But they won't be able to do anything without some idea of the kind of Docker containers you'd like to build. For that, we'll create two files here in our local directory, docker-compose.yml and ecs-params.yml. Starting with docker-compose, notice how we specify YAML version 3. ECS currently only supports versions 1 to 3, which means that many features of 3.1 and 3.2 and so on just won't work. In any case, we define two services, WordPress and MySQL. The WordPress definition points to the most current official WordPress image available on the Docker Hub. It opens port 80 for unencrypted HTTP traffic and, importantly, establishes a connection to the MySQL server. Nothing will work without that detail. The MySQL service will use the official version 5.7 MySQL image. You could add an environment section to this definition, which includes the MySQL root password WordPress will use to access the database. This is something that is critical if you want your WordPress site to work, but it's not a great idea to do it this way from a security perspective. So instead, I'll export my ultra-secret, impossible-to-guess database password from the command line, and the ECS CLI will hopefully pick up the reference in the YAML file and read it from the shell environment. The other YAML file, ecs-params.yml, adds some resource limits to our service definitions. In this case, both the WordPress and MySQL containers will get as many CPU shares and allocated RAM as is noted here. These are fairly widespread default values, but you can edit them if you find they're not working for you. With that taken care of, I'll use ECS CLI compose to deploy our containers. The cluster config value points the CLI to the cluster we just created, and we'll name the project using project name. Service up will, as you can guess, set the service in motion. This will launch your actual application, and I'll prove that it worked in just a minute or two after everything here settles. But while we're waiting, I should tell you that you can apply updates to your containers by editing the YAML files or the images on which they're based, and then coming back here and running this ECS CLI compose command once again. If the operation should tragically fail, returning some kind of error, you should carefully note the message to see if there's anything obvious you might have missed. Misspelling a resource name in a command or even in a YAML file is common. Other error messages could point to syntax errors, or if the cause isn't obvious, could lead you to productive internet search engine sessions. Remember to treat all failures for what they are. Fantastic opportunities to learn more and better understand the technology you're using. But this time we seem to have reached a happy and successful conclusion. Let's run PS against the cluster configuration name to retrieve some important runtime information. This shows us an accessible IP address open to HTTP traffic, so I'd say we should head off in that direction using a browser. And what do you know? It's a WordPress setup screen. We wouldn't get this screen if WordPress hadn't successfully connected to the MySQL backend, but just to remove any doubt from your mind, I'll create an admin user and log in. Perfect. While we're sitting in front of the browser anyway, I'll head over to my AWS console and take a look at the running EC2 instances. There are, as expected, two. This one is the same public IP we just visited, which means the other one would be hosting the MySQL server. In the next clip, I'm going to be putting together a simple application using Fargate, but there won't be any EC2 instances visible from the console. Remember, Fargate is a managed service, so all the bits and pieces are hidden from our meddling human eyes. Before we leave this clip, however, I should tell you how to shut all this stuff down. Leaving it running when you're not using it will generate charges, nothing enormous, but they will add up over time. You should also double check on the console to confirm that there's nothing left. You should see nothing running on the EC2, ECS, and CloudFront dashboards. Why CloudFront? Because ECS uses CloudFront stacks to manage a cluster's resources.